Welcome to AI Frontiers. Today's episode explores a snapshot of modern robotics research through 47 papers from December 7th and 8th, 2025. This collection reveals robots that learn, navigate, and collaborate, showcasing the daily heartbeat of embodied intelligence. This presentation will explore 47 papers from a single day in robotics research. The journey will uncover dominant themes shaping the field's future, examine breakthrough methods and key findings, spotlight 3 seminal papers defining current ambitions, and chart the path forward for intelligent machines. The field of computer science robotics represents the engineering of autonomy. It focuses on building machines that act intelligently in our world through the convergence of artificial intelligence, machine learning, and physical design. The field has moved beyond pre-programmed industrial arms to create agents that perceive, reason, and execute physical actions. This work transforms code and algorithms into world-altering capability. A dominant theme emerging from the research is learning to act and imitate. This represents a paradigm shift where robots are taught rather than programmed. Deep reinforcement learning enables robots to learn from consequences through trial and error. Imitation learning involves copying expert human or robot behavior. Foundational pedagogical guides are provided by Santana and colleagues, while Kim and team's Espada system speeds up learned policies for real-time use. The second critical theme is the integration of foundational models. Researchers are creating vision-language action models by plugging powerful AI brains into robotic bodies to create generalist policies. Work by Chen and colleagues and Lychenko and team builds systems that understand commands from both words and visual input. A key challenge is addressing brittleness and the memory trap problem. Hybrid architectures such as Zhu and team's affordance field intervention combine neural networks with classical reasoning, marrying intuition with logic. Theme 3 is navigation and mobility in complex worlds, addressing the fundamental challenge of motion. Research spans from humanoid stair climbing and graceful leaping, as demonstrated by Song and colleagues, to drone swarm coordination for collaborative disaster response by Papakostas and team. Gadvi and co-authors plot energy-efficient paths for autonomous boats through ocean currents. Moldaliava and team's DB-LACAM algorithm prevents collisions for dozens of robots in busy spaces like warehouses. Several critical insights across the research point to inflection points for the field. One is one-shot video imitation for generalist manipulation, achieved by the ViVLA system from Chen and colleagues, which enables learning from a single human demonstration. Another is the decoupling of perception and action for scalable navigation through Milikich and team's VLD framework, which breaks the sim-to-real bottleneck. A third is real-time expressive motion imitation across different robot body types, enabled by Herman and colleagues' method for graceful, natural robot movement. The roboticist's toolkit, synthesized from the 47 papers, includes several key methods. Deep reinforcement learning facilitates trial and error learning guided by reward signals. Imitation learning, or behavior cloning, learns from expert demonstrations. Model predictive control provides optimization-based planning with explicit constraint handling. Variable projection exploits mathematical sparsity for hundredfold speedups in computation. Finally, hybrid neuro-symbolic frameworks combine data-driven learning with logical or geometric reasoning. The first spotlight paper is See Once Then Act by Guanyan Chen and colleagues from 2025. It presents ViVLA, a vision-language action model for one-shot learning. The system watches a single expert demonstration video of a novel task and then executes it. A brilliant data pipeline turns internet videos of humans into robot training data. The model showed over a 30% improvement on the challenging Ligero benchmark. This work points toward foundational understanding models for robots that enable rapid skill acquisition. The second seminal paper is VLD, Visual Language Goal Distance, by Lazar Milikich and team from 2025. It solves the end-to-end navigation bottleneck by decoupling perception from action. A perception model is trained to predict a distance-to-goal score using millions of internet videos. A separate control policy is then trained entirely in safe, fast simulation to minimize this predicted distance. This separation provides a consistent objective that bridges simulation and reality, enabling scalable and robust navigation. The third paper is the Comprehensive Review Towards Seamless Physical Human-Humanoid Interaction by Gustavo A. Cardona and colleagues from 2025. It provides a roadmap for the entire subfield, analyzing three technical pillars: humanoid control, human intent estimation, and computational modeling of the human body. The review identifies critical integration challenges between these pillars and proposes a unified taxonomy of interaction types. It serves as an essential guide for building socially intelligent, intuitive, and safe robot partners. The path forward for robotics research includes several key directions. There is a push toward foundation models that encapsulate physical common sense and action generation. Human-in-the-loop and interactive continuous learning will become central, with robots learning from natural feedback. Advancing long-horizon reasoning is critical for orchestrating complex multi-step tasks. Finally, real-world validation and benchmarking at scale, including automated testing platforms, will be essential to prove robustness and safety outside laboratory environments. This synthesis was created using several AI tools. Content was synthesized using the GPT DeepSeek model. Text-to-speech synthesis was performed via DeepGram for audio narration. Image generation concepts utilized Stable Diffusion for visuals. A human expert review was conducted for accuracy and coherence. It is noted that while reviewed, some oversights may still exist. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.